What's up, sports fans? Here's your day 2 video for Unit 2 of Semester 2 of Algebra 1 class. If you haven't watched the day 1 video, I explained all the items. Day 2 is just a day to practice. I have a whole bunch of practice problems. Here are the assigned practice problems, page 7, number 23 to 23 to 38, and then page 9, we'll look at a test-like question, number 40. This is a big one. Please make sure you watch this one. Nerds in the room, please add the following problems. I won't be discussing them probably in this video. We'll see what time allows. Okay, page 7, number 23. This is page 7, here's number 23. Name each polynomial based on its degree and number of terms. Again, if you watch video 1, I said I'm not so concerned about the degree, but I am concerned about you understanding whether it's a monomial, binomial, trinomial, or a polynomial. There are 3 terms, 1, 2, 3. Think of a tricycle, this is a trinomial. Here again, 3 terms, 1, 2, 3, trinomial. You can see this is a 3rd degree because the biggest exponent is 3. You can see this is also a 3rd degree because there's an exponent of a 2, but then there's also this sneaky y to the 1st power. So you have 1 plus 2 making 3. Here you have a 2nd degree because the biggest exponent is 2, and it's a binomial, 2 terms. Here, 1, 2, 3, 4 terms, making it a polynomial, and then it's 4th degree because the biggest exponent is a 4, no other variables sneaking in there. Moving forward, number 27, notice how I use colors here to combine like terms. So our x's, we have 3x minus 4x minus 5x. 3 minus 4 minus 5 lands us here at negative 6x. I really should have started by talking about the red stuff first because we're writing this in standard form. That was my mistake. Standard form, remember, the biggest exponent goes out front. So our x squared terms, 2 here, 3 here, that makes 5. So this is all written correctly. I should have talked about the red stuff first. I will do that moving forward. Here, looking at our y squareds, there are 8 of them here, minus 12. 8 minus 12 is negative 4. So combining like terms, we have negative 4y squared. Now in blue, we have a 3y, no other y's to combine it with. 3y stays 3y, same is true with a constant value of 5. Looking at 29, these are all z's. The biggest exponent I see is a 2, so we're going to combine all those together. Negative 7 plus 5 plus 2. Well, check this out. 5 plus 2 is 7. This is a negative 7. 7 minus 7 is 0. The z squareds go away. They cancel each other out. Interesting. Now looking at the z's. 3 here, minus 5 here. 3 minus 5 is negative 2. Moving on to number 30. The biggest exponent I see is this one here in red, the x squared, and there's no other terms to combine it with. 4x squared stays the same. Now looking at our x's, the stuff in green, negative 2 plus 5. If it helps to look at this as 5 minus 2, you're welcome to do that. It means the same thing. 5 minus 2 makes 3. There are 3 x's. Looking at our constant values here underlined in blue, 7 plus 3 makes 10. Okay, playing the same game here, I just didn't show as much in my process, but it's the same deal. And you're also welcome to look at yesterday's day 1 video if you if this isn't clicking. Add or subtract, write each answer in standard form. That means the biggest exponent goes out front. The adding ones are just like what we did above, combine like terms. There's 3 b's here, there's 7 b's here, 3 plus 7 makes 10. Here there's a negative 8, here there's a 4, negative 8 plus 4 is negative 4. Moving forward, again, we're adding, just combine like terms. The tricky part about this is this trinomial is not written in standard form. So identify the largest exponent you have, it's a 3. Do we have any matching ones over here? Yeah, we do. Negative 8x to the 3rd. So negative 7 minus 8 is negative 15. Now we look at the squareds. There's 2x squareds here. There's negative 3 of them here. 2 minus 3 is negative 1. You can see I made a mistake here. Minus 1x squared. Then we are looking at our x's. Here there's 8x, and there's nothing to combine it here. So 8x stays the same. This one has a constant value of 4, and there's no constants over here. Nothing to combine it with, it stays the same. Moving, I'm gonna skip number 33 and 34 just for a second, I'll come back. I wanna stick with the adding, and then I'll do the subtracting ones back to back. This one's adding, so same process, combine like terms. M squared is the biggest variable or exponent here, same is true here, 4 of them, 2 of them, 4 plus 2 makes 6. Now looking at our m's, there's minus 2 of them, negative 2, and then there's a plus 2. Negative 2 plus 2 is 0. The m's go away. That's why they're not reflected in our final result. Now we got 4 plus negative 5, or 4 minus 5, that's negative 1. So this one is complete. Bouncing back to number 33. Same idea, but there's one added layer. We are subtracting each of these items, so you can distribute a negative. I didn't show that, but that's what's going on behind the scenes. So this is a y squared minus 1y squared. So 5 minus 1 is 4. Now looking at just our y's, negative 2 minus 1y. Negative 2 minus 1 is negative 3. That's where this comes from. Now looking at our constant values, 1 minus 3. 1 minus 3 is negative 2. Number 34, the biggest exponent here is a 4, and it's in both, even though they're written in a funny order. So we got a negative, negative. This one's going to be a little bit wonky. Negative 7 minus a negative 7. Well, minus a negative is the same thing as adding. So now we have negative 7 plus 7. That's 0. That's why there's no a to the 4th power over here. It canceled out. Now the next highest exponent is a 2. That's reflected in both of these trinomials. We will combine these. 4 minus a negative, or 4 plus 8. 4 plus 8 makes 12. So we have 12a squared. Now looking at just our a's, negative a minus another a. It's already negative, we're subtracting, so it's getting negative. Negative 1 minus 1 is negative 2a. This one is now complete. Number 36, perimeter. Find the perimeter of the rectangle. Perimeter just means the area or the length around the outside. If this was like a grass field and the outside border was a fence, we're finding the length of the fence. Area is a fundamentally different thing. We'll discuss that later, but that would be the amount of space on the inside of the fence. Perimeter, we're just adding up the 4 sides. If this one is 3x to the 1st power, so is the other one. That's what a rectangle is. And then the shorter sides are both x plus 1. So we're adding this plus this plus this plus this. You can see it reflected here, combining like terms. 3x plus 3x is 6x, plus 1 more x is 7x, plus 1 more x is 8x. That's where this came from. Now the constant values, negative 1 plus a negative 1 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. That's why there's nothing here. They cancel out. Negative 1 and 1 cancel, negative 1 and 1 cancel. That ends up being a 0. This problem is complete. Let's look at these last two. A cube has square sides with an area of this. What expression represents the surface area of the cube? This is what a cube looks like. It's got 6 sides to it. And so all we are doing for this example here, if each side has an area of this, we are simply taking this value and multiplying it by 6. So we distribute the 6 into these. I did that over here on number 37. You can see it on this page with a little bit more room. The cube has 6 sides, so we took the area of one side, multiplied it by 6. 6 times x squared is that, 6 times 24x is this, 6 times 144 is that, and this is complete. Number 38, a rectangle has a length of this and a width of this. What is the perimeter of the rectangle? So this is just like number 36, but there's no picture. So if this is the long side, well, we got 2 of them. So 5x plus 2, 5x plus 2. Then the width is the shorter side, 4x plus 6. We got 2 of those sides as well. Simply add all these together. First the x's, 5x plus 5x is 10x, plus 4 more x's makes 14. 14 plus 4 makes 18. That's where this comes from. Now the constant values, 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 6 is 16. This is number 38. Now, the last one, page 9, number 40. This one is going to look like, or this one looks like what you're going to see on your upcoming exam. Number 40, it's got a picture, there's houses, and there's rooms in a house and stuff. The owners of a house want to knock down a wall between the kitchen and the family room. What expression represents the area of the new combined open space? Well, the family room is given to us as an area of x squared plus 10x plus 24. So that's this x squared plus 10x plus 24. Sorry, it's sloppy. If it helps, I can throw that in parentheses. This is the family room right there. The kitchen, it has an area of x squared plus 7x plus 12. Again, we didn't calculate. That was given to us. That's just fine. That's this stuff. So we're adding the 2 trinomials. I know it's wordy, I know there's a picture, but this is exactly what we just did on the previous page. Combine the x squared. One of them here, one of them here, 1 plus 1 makes 2. Our x's, there's 10 here, there's 7 here. We are adding 10 plus 7 makes 17. Constant values, 24 plus 12 makes 36. That is it for most folks. For the nerds in the room, we can. There's a few more for you to look at. I'm not going to discuss them in this video. Happy to answer your questions. You can check the answer key and all of that. Thanks for listening. You rock.